Okay, so okay, so let's start with chordates. So we're all members of chordates. The primitive chordates do not are invertebrates. Okay, and then from there we have uh, vertebrates. So the vertebrates are all right here. Okay, so these are invertebrates. The ones above are vertebrates. Okay, and then some of them have jaws, tetrapods, and last but not least, amnions. So let's talk about what these things are. The most primitive invertebrates are still chordates. Okay, so these are chordates. These are lancelets and tourniquets. These are what they look like. Okay, they have really like a lancet is probably the more classical definition of what a invertebrate chordate looks like. It basically looks like a small fish, but it doesn't have any bones in it. It just has a little tiny rod, the notochord that holds it up. And they're really small. They're only about 2 or 3 centimeters large. Okay. So moving on, we have a cranium. We have a skull now. Skull offers protection around the brain. So now you have more of a brain. Okay. And so you have hagfishes and lampreys. Okay. So this is where the formation of skeletons are. Okay. So lampreys, hagfishes don't really have a skeleton. Lampreys do, but their skeleton is made out of cartilage. Okay. So it's much softer and much squishier than bone. And then finally, we have fishes. Fishes are true aquatic vertebrates with jaws. Okay. Okay, so here are aquatic fishes with jaws. The most primitive of those are the sharks. Okay, so sharks have jaws, but they still have a cartilage skeleton. Okay, and then here you have a swim bladder, pair fins, and these and true bones, which make up bony fishes. Okay, bony fishes split into 2 groups: ray fin fish and lobe fin fish. Okay, the lobe fin fishes, because of the shape of their fins, allow them to move on to land easier. So they got land first. Okay, and these are and they also have lungs that can breathe air when the water is muddy or scarce and stuff like that. So lungfishes, for example, they live in the water until the water dries. They live in riverbeds, and then the riverbed dries out. And when it dries out, they literally dig themselves a hole and sit in that hole, and they breathe air. Okay. Okay. Um, okay. So amphibians live double lives. So amphibians, okay, the low. Sure you learn about tiktaalik by now. Tiktaalik turns into amphibians, right? These are amphibians. Amphibians live their life on land, but they have one major issue, and that one major issue is that they have to want to stay wet most of the time. But even if they don't need to stay wet, like toads and stuff, they still need to return to the water to lay eggs. Okay, so again, you see the same problem in plants and animals. When they come out of the water, they have to, the more primitive members of the species have to return to the water for reproduction. Okay, so reptiles were the first vertebrates to truly thrive on land, and they are adapted in two different ways. One, their skin is drier, and therefore they're adapted to retain water outside inside their bodies and reproduce outside of it. Okay, and that comes with the amniotic egg. Okay, so the egg, you can see the eggs of reptiles look very different than the eggs of amphibians. The eggs are much bigger. The animal stays inside the egg for much longer. Okay, and they have a yolk. Okay. All right. All right. Reptiles live and reproduce on dry land. So reptiles evolved from about 310 to 320 million years ago. So they reduce water loss from skin due to scales. Okay. They have internal fertilization, amniotic eggs, so they can lay eggs and reproduce outside of water, and therefore they can live on there. Okay. So these are reptiles, including birds, technically are should be in reptiles. Okay, now out of the amniotic egg layers, we have mammals. Okay, mammals also have an amnion, and so mammals are closely related to reptiles. Okay, they're endothermic amniotes with milk secreting mammillary glands. Mammals also produce hair, which help produce conserve body heat. So even things like dolphins still have body hair internally, but they don't actually produce body hair on their surface. Okay, but they do have body hair as embryos and stuff. All right. So now, since we're mammals, let's take a closer look at mammals. Okay. So this is a summary of coordinate diversity. So now let's look at mammals. Okay. So out of mammals, okay, so let's go through mammals really quickly. I'll do that. So mammals have three groups: monotremes, marsupials, and placentals. Monotremes still lay eggs. Marsupials continue to they give birth, but they don't have placenta, so they give birth to a really immature baby. And that baby comes into the pouch and develops there for many months. Okay, placentals are directly connected to the mother's uterus through the placenta and use her circulatory system for a very long time. Okay. Okay, so humans are in a group called placental mammals, called primates. So we are primates. Make sure you know the definition of primate because that won't be on test. Okay, so this is us right here. So again, you should know the dots. Okay, so we are a group of primates. So all primates have opposable thumbs, flat nails, binocular vision, large brains. Okay, out of that, we are apes, and by definition, we have long arms, short legs, and no tail. Okay, out of these guys, we are a group called great apes. Okay, and so great apes are orangutans, gorillas, bonobos, chimpanzees. It says fist walking here, but that's not really the only characteristic. The the major characteristics is the size of the brain. We have larger orangutans, and all these guys are larger than gibbons, and they're bigger brain size. Okay, and then out from here, we are most closely related to chimpanzees. Okay, and what makes us human really is the bipedalism, which led to longer legs. Okay, so we are a type of great apes. Okay. Okay, so you see skulls. Okay, we can also look at the molecular data. It's the same thing. The molecular data suggests that we are very closely related to each other. Okay. Human evolution is partially recorded in fossils. Okay. Forward a little bit, talk a little bit about different populations. Okay, so there's many different populations of hominids, and you can see that here. You can see that in the latest video I put out. Okay, and we are here. So all these other homo species are extinct. So Homo habilis, okay, etc. All the way through. Okay, all right. So hopefully that makes sense to you guys.